Good day, guys. So today we're going to be learning the laws of indices. Okay. Now, this topic looks kind of hard to some students, look kind of intricate to some students, but it's actually a very, very simple topic. You're in the right channel where you're going to be learning all the laws of indices. Now, I promise you to watch this video to the end. Now, when you watch this video to the end, I promise that you'll be able to tackle any indices question in JAMB, in WAEC, NECO, whatever it may be. Because the secret to solving those complex indicial equations that we see is by knowing the foundation, which is the laws. So when we know these laws very well, when we watch this video to the end, and we are sure that we know these laws very, very well, I bet you that WAEC, JAMB, NECO, anything that concerns indices in these exams, you are going to haze them. So now, let us delve in. So now, what is indices to begin with? Now, indices is just like is a method, okay, for simplifying or for evaluating powers, okay, numbers or letters that have powers. How do we simplify them? How do we evaluate them? Okay, so mathematicians came up with different laws that helps us to analyze numbers that have powers and letters that have powers. Now we have the laws of indices. Now the first law we'll be talking about is the multiplication and division law. Okay, that's the first fundamental one. Multiplication and division law. So we'll start with the multiplication and division law. Now, what does this law state? Now, for multiplication first, it says that when we have a to the power of m, for example, times a to the power of n, okay, a to the power of n, it will give us a to the power of m plus n. It means that when you have two numbers or two letters that have the same base. Now, in indices, this here is called the base, while this one you are seeing up here is called the index or the power. You can either call it index or you call it power, the same thing. But why this that is carrying the power is called the base, okay? So when we have two bases or more that are the same, we are going to add their power when we are multiplying them. The same goes with division. When we are divided by a to the power of n, we are going to subtract their power. That is the opposite. We're going to do the opposite. For multiplication, we had. For division, we subtract. So what this law is telling us is that, okay, let's say we end up being mathematicians, then while solving, we come across on things like 3 to the power of 2 times, let's say 3 to the power of 1, for example, and we have to evaluate this. What do we do? Since they have the same base, okay, these two here are the same. Now we can just pick one and add their power since we are multiplying them, okay? So 3 to the power of 2 times 3 to the power of 1 will give us 3 to the power of 3. As simple as ABC, it's not hard. Same thing as division. If we were dividing, for example, we're going to subtract the power 2 minus 1, which will give us what? 1. Okay, that's just the simple multiplication and division law. Are you following? Now, this is when they have the same base. And there can be some other ways whereby they might have different base but the same power. How can we do something like that? For example, let's say that this is an extension of this law. Let's say this situation 1, let's say situation 2 now. They have different base. Let's say b to the power of m times b times c to the power of m. Now, in this case here now, they have different base, but they have the same power. How do we evaluate them? Very, very simple. What we're going to do is that we're going to multiply these two base and give them one power, okay? What I'm saying is that this will be evaluated as bc to the power of what? M. Okay, that is, we join the base together and let them share one common power if they have the same power. Are you following? Here now they have the same base. We pick one base, then we evaluate the power. The opposite is happening here. When they have different base, we take the two base, but we pick one power. So that's that about that. That's when they have different base but the same power. What of when they have the same base and the same power? For example, when they have the same base and the same power, how do we evaluate them? You can use any of this method here. You can use any of this method, okay? You can use any of it to evaluate this, okay? You can either say that pick one base, right? Then add the two powers together, which will give us b to the power of m plus m is 2m, right? Or since they have the same power, we can also do b times b and give them one power, and b times b will give us b squared, right? Will still give us b to the power of 2m because b times b is b squared. So whichever way we do it. Now, the reason why I'm extending this rule is that sometimes when we see some situations like this, you should know what to do. Are you following? Sometimes they might not only have the same base, okay? Sometimes it might be that they have the same power. So in summary, what this law is telling us is in summary is that when you have two different bases, right, that are multiplied or divided, when they are added, please, this law does not work, okay? Because indices have to do with power, that's multiplying repeatedly. To the power of 2 means multiplying twice, not adding twice. Are you following? So addition and subtraction does not work with the law of indices, right? So only multiplication and division. So when you have two bases that are multiplying, for example, you have two numbers you're multiplying. It's either they have the same base or they have the same power. When they have the same power, we can use the multiplicative law for it. Or when they have the same base, we can use this law for it. Are you following? So they must have something in common. But now the third case is when they don't have anything in common. For example, you have a raised to power b times c raised to power d for an example. No common power, no common base. These cannot be simplified. They must have something in common. Are you following? These cannot be simplified. Same as with the division. As simple as that. So that's the first category of the law. Okay. Now let's go to the second category of the law. Yes, and please, before we move to the next law, let's put in mind that the reverse is also the case, okay? What I mean is that let's assume we have something like this. We have a base and we have m plus n for an example. You have a base that has an added index. We can also split this and reverse it to a to the power of m times a to the power of what? N. What that means is that when you have a power that is added, that they share one base, so we can split that addition to the base raised to power 1 times the base raised to power the other one, just like the opposite of the law. Same as with the division. When you have subtracted power, okay, now you can also split it into what? Division. Because according to that law, when you divide, you're going to subtract the power. And please don't forget, this division can also be in this form. Don't let us be confused. Okay, can be division or over. It's still the same thing. We pick this power minus this power. Okay, we subtract. Pick one base and we subtract the two. So now, what is the next law we are going to be dealing with now? Now, the next law of indices that we'll be dealing with is we call it the zero index. Zero index. Now, what is the zero index? Zero index tells us that whenever you have a number raised to power 0, it gives us 1. Okay? Any number, any letter, not any number, any non-zero number, 1, -2, 1 million, 1,000, x, y, any letter, any character raised to the power of 0. Okay, in mathematics gives us what? 1. Now, some students are always confused that why, how come this one gives us 1? It's kind of odd and strange. Now, let me tell you the reason. Now, if we say a to the power of 0 gives us 1, how? Now, we can rewrite a to the power of 0 as a to the power of 3. Let me make it bold. A to the power of 3 minus 3, right? Because 3 minus 3 gives us what? 0, okay? Now, also this one, we can write it as, don't forget I told you before, that when you are subtracting power, okay, we have a base, we are subtracting the power, we can convert that subtraction also to division, okay? That is, we can split them and write it as a to the power of 3 divided by a to the power of 3, okay? Same thing, because 3 minus 3 gives us 3 minus 3. Now, so a to the power of 3 divided by 3 to the power of 3, as we have guessed, this cancels this and gives us what? 1, okay? So that's why, now it can work for any number, okay? It can be 4 minus 4, 5 minus 4, it doesn't mean. So what this means generally is that any non-zero number or letter raised to the power of 0 give us 1. If it was with 0 to the power of 0, for example now, it's going to give us math error. There's not equal to 1, give us math error. Why? Because 0 instead of a now we have 0. When we say 0 to the power of 3 divided by 0 to the power of 3, don't forget in mathematics, we can't have a division of 0. Any number divided by 0 will give you infinity, or undefined. Okay, that's a mathematical error. So that's why 0 to the power of 0 cannot give us 1. You can check it out in your calculator, okay? You can input 0 to the power of 0. Let's see, you see math error. Now, so this law now can have some twist. Sometimes it can even be compound. It can be compound. For example, we might even have, let's say, 3x squared minus my plus z all to the power of 0. You know WAEC now, WAEC, NECO and all that, they like to twist questions. No matter how long it might look, okay, as far as they all have a power of 0, everything has a power of 0, all this here is going to equal to 1. No matter how long the question, this expression can be as long as this place down there. It doesn't change anything. As far as the raised to the power of 0 gives us what? 1. And also these laws here we have evaluated. These laws, I'm trying to go to all the corner that WAEC or NECO might pass through. Okay, so even this one, we might even have a to the power of m minus n all squared, let's say, times a to the power of, let's say, b c d m cube minus 3, whatever. You know the way JAMB and stuff can manipulate questions. Now what I'm trying to bring out here is that sometimes the power might be compound, might not be just one character like this. It might be compound, doesn't mean. As far as we have the same base, whatever the power might be, okay, we are going to add, no matter how long the power is. But there's just one thing we must be careful of, to include brackets, please. Include what? Brackets, so you don't make mistake. What this means is that you can say this is a to the power of n minus n squared times is plus everything here, because of it is compound, please use bracket, okay? B C D m cube minus 3. Now, you can now simplify this normally. The way you simplify a normal algebraic equation, okay, simplify, expand the bracket, rearrange and all that, but doesn't mean, no matter how complicated it is, the law still follows, okay? Now, let's go to the next law. Okay, now, so the next law we're talking about is the negative index or negative power. Okay, negative index or negative power. What is the meaning of negative index or negative power? It means that when you have a number, right, and the power is negative minus m. Now, so far we have been having positive powers. What of when we have a negative power? How do we simplify a negative power? This law tells us that whenever you have a negative power like this, we can simply eradicate this negative power, because we don't like negative powers, okay? We can easily eradicate this negative power and change it to a fraction, 1 over. That's this minus alone, okay? This minus alone, that's the way you can just visualize it. This minus on its own becomes 1 over. Like this 1 over is in place of the minus. Are you following? I know why I am stressing on it, because students used to make a lot of mistakes. Please, students used to make a lot of mistakes. I'm going to highlight that mistake very soon. So it becomes 1 over a to the power of m. So whenever we have a negative index, we change it to a fraction like this. It can also be the other way around. Also, when you have a fraction, let's say you have 1 over, let's say, x to the power of y. We have a fraction like this. There is an index is in a fraction, a base and the power as a fraction. We don't like that also in some cases. We can also convert it to a negative power. Okay, don't forget 1 over represents negative power. So the fraction, this 1 over as a fraction will be eliminated. So we have something that is linear like this, then negative y. So I've eradicated this fraction and changed it to minus. I follow. So it depends on the situation. There's some situation whereby it might be better in a fraction way, or some cases might be better in a negative power. Whichever way, okay, you can convert vice versa. Now, what are some of those errors that students can make? For example, when these have a coefficient, let's say we have something like, let's say 3a to the power of negative 2. So let's say 3a to the power of negative 1, for example, right? So when students want to convert this, okay, when they want to convert it, they'll say 1 over 3a. This is a very, very wrong, it's a mathematical blunder. It's very, very wrong. Are you following? It's very, very wrong. And the reason why this is very, very wrong is because this power belongs to a alone. It's affecting only a, right? So that means the fraction is going to be just a. What I'm saying is that this 3 because it does not have a negative power, it does not convert to a fraction. Only this has a negative power, so it converts to a fraction. So just this alone becomes the fraction. Don't forget this negative, this minus, okay, becomes over then a to the power of 1. This is the correct way of evaluating it. Are you following? This is the correct way, no mistake. And also, it doesn't mean, okay, the power can be in any way. It can be any number, rather. It might even be 3a to the power of negative 4. Doesn't mean, we still give us 3 all over a to the power of 4, right? So it's this minus that is becoming the fraction. I for this minus is converting to the fraction, they will still have the power. Or an easier way to write this so you understand it better is by saying, now this 3, just say 3 times, are you following? 1 over a to the power of 4. You can also write it in this convenient way. It means that this minus becomes 1 over. We separate the 3 from it because this 3 does not have negative power. Separate 3 from it. So we have 3 times. This one here becomes a fraction like this. Are you following? So 3 times 1 give us 3 all over a to the power of 4. Any convenient way you can. But just know that these two are actually different. Now, for this to work, it means that the question must be in this format. Let's say we have 3a all to the power of negative 2. This is a different case. This negative 2 belongs to 3 and also belongs to a. Hence, the bracket that is there. Here now, we can now say this minus becomes 1 over 1 over. So these 3 that have the negative, these two numbers, sorry, these 2 have the negative power. So this 2 becomes a fraction. The bracket is still there, okay? It's just this minus that becomes 1 over. As simple as that. Another error that student might make is, now when we are doing the reverse, okay? Let's say we have something like, let's say we have 4 all over, let's say 4 all over 3 to the power of 2, for an example. 4 all over 3 to the power of 2. Now, some students, when they want to convert this to negative power, they will have a lot of problem. In fact, they won't even know where to start from. But this is actually very, very simple, okay? Now, the best way to do this is by separating it. Are you following? By separating, there is this 4. Separate this 4. This 4 is a whole number. It's not a fraction. Separate it from the fraction times 1 over 3 squared. Are you following? Separate this 4 from the fraction because 4 times 1 still give us 4. So the best way is just like split them. The coefficients, take them away. That is the whole numbers, take them away. Fraction, it can even be 3 letters. It can be 4ab. Not to concern us with that. The 4ab, separate it from the fraction. But this one must have 1 over. That's the thing. So now this 1 over now, don't forget the opposite of that law. This 1 over becomes a negative power. So here we have 4 times 3 to the power of negative 2. As simple as that. Okay? So that's that about the index. Please, let's avoid these silly mistakes. The next law now is power of a power. What is that? Power of a power. Now, what does this mean? It means that when you have a number or a letter that has a power and it has another power, what it means is that there's a power here and there's another power here. Okay, now what do we do here? How do we evaluate this? What this law tells us is that we are going to multiply the two powers. Okay, what this is that we have a number raised to power 5, for example, a number raised to power 5, all raised to power 2. Can you see that number have a power? Then it's having another power. That's the power of a power, of a power, of a power, of a power. It can go on repeatedly like that. Okay, so whenever you have a power and another power, okay, beside it, what we're going to do is we're going to multiply the power. We're going to multiply the word power. Now, there's another error because I have some years of teaching math, so I know a lot of errors that students do make. There's another error you can encounter here too, that you can make here rather. Now, that error is that some students they don't know the difference between when to multiply power and when to add power. In fact, I have been a victim of this before also when I was a student. Sometimes I'll be like, oh, what do I do here? Do I add the power or do I multiply the power? Because I have a law that deals with addition of power, here and multiplication of power. How do I know? Please know that when you have two base, you what? Add the power. This power will be added. When you have two bases like this, okay, the power will be what? Added. When you have just one base, okay, you have one base, power of the power, it will be what? Multiplied. Now, the trick you can use here is just like say, okay, I have a power and a power. Oh, what will I know what to do? Just know that, for example, if this one were to be 3, for example, if everything here were to be 3, let's say 3 raised to power 2, raised to power 2. We know that raised to power 2 means we multiply in 2 places. So since we are having a power has to do with repeated multiplication. So when I have a power, I'm going to be multiplying, not adding, okay? Power is repeated multiplication. So now I'm having the power of a power. So this power signifies repeated multiplication. So that means I'm going to multiply the two powers, not add. As simple as that. Now, there might be a lot of WAEC now, JAMB. And I make it look intricate from this law. Even if you have a to the power of m times b to the power of negative y times c to the power of 2x all to the power of 2, for example. Now, look at this one here. Look at this one here now. This one now we have 3 different bases, right? 3 different multiplied bases, all having one power. This law still applies, okay? When you have power of a power, we multiply the powers. But here now, because we don't have only one base, we don't have only one letter here, we have 3 different letters. It means we are going to share the power to all of them. We're going to share the power to all of them. So this one will be a to the power of m times 2, that's a to the power of 2m, times b to the power of 2 times negative y, that's negative 2y, times c to the power of 2x times 2, that's 4x. Can you see? So no matter how long the bracket might be, as far as they have a power, what we're going to do is that we're going to share the power to everything in the bracket, okay? Now, another error students will make. Yes, so because of this law here now, so they might be having the foreign idea of saying, let's say we have a to the power of m plus b to the power of negative y all squared. Oh, yeah, we have the power of a power. Okay. So what we do is that we share the power 2 times m, 2m plus b to the power of, 2, that's negative 2y. Yeah, simple. Simple as ABC. No, this is very, very wrong. Like I've said before, this is the kind of an extension of this addition here. I told you that this law deals with multiplication and division, not addition and subtraction. Indices, power have to do with repeated multiplication, not addition. It has nothing to do with addition. Okay, so we are adding here, we are not multiplying. Please don't use the law. Law of indices works only with what? Multiplication and division. 2 to the power of 5, you are multiplying 2 5 times. You are not adding 2 5 times. So we have nothing to do with addition. So don't use any law of indices when addition and subtraction is involved. If they're not multiplied or divided, you can't share the power. Okay? But if we have a to the power of m all over b to the power of negative y all to the power of 2, is division here. Okay, yes, we can share the power. 2 multiply this, 2 multiply this. We can share the power for them. Okay, so that's that about that. Please don't make these mistakes. And another complication again we can get from WAEC. Let's say we're having lots of powers. Okay, let's say we have something like a to the power of m to the power of n to the power of p, okay, to the power of z to the power of q, and so on and so forth. No matter how long this might be, we're still going to use multiplication. But let's start from the outermost part. Okay, outermost part. Okay, that's q times z. We multiply the power, multiply till it gets to this base here. So that be qz, that's qzpm, qzpm squared. Multiply all the power, no matter how long it might be. So that's that about that for the power of the power. Now to the last law. Okay, so the last law has to do with what? Roots. When we have roots, that's the last law. We have what? Roots. How do we evaluate roots? Okay, when we have roots, might be square root, cube root, fifth root, and all that. How do we evaluate roots in indices? Now let's say we have m root of a. Now m root of a, according to law of indices, will give us a to the power of 1 over m. a to the power of 1 over m. So what this law is talking about is that whenever you have a root, you can convert a root to a fractional power. That's just it. Okay, just like the way 1 over can be converted to negative power, same way as root can be converted to fractional power. Now, depending on the value of the root, for example, m root, are you following? So if you have square root of a, for example, that would be a to the power of 1 over 2. Are you following? If you have cube root of a, that would be a to the power of 1 over 3. What I'm saying, if you have 3 cube roots of a, will give us a to the power of 1 over 3. So roots have to do with fractional power, can be converted to fractional power. And that's not that. The reason why we have 1 here is because the power of a is 1. Okay, so in a situation whereby a has a power, for example, let's say a to the power of 3, that will be the fourth root of a to the power of 3. Now, this one will give us a to the power of 3 over 4, not 1. 3 over 4. The reason why it is 1 here is because the power of a here is 1. Okay, but here now, the power here will be the numerator, the root here will be the denominator. In fact, in summary, okay, whenever we have roots, we can convert it to a power. Now, the numerator of the power represents the power of the base, while the denominator represents the root. Denominator is root, numerator is what? Power. That's that about that. It is not what? Hard. Very, very, very simple. There is a common mistake that students do make again. Mistakes. Let's watch out for them. Now, something like 4 root a to the power of m is not equal to fourth root of a to the power of m. They are not the same. Don't make that mistake. Okay. Now, 4 here is a coefficient, is a multiplier. 4 here is a coefficient, is a multiplier. It is not fourth root of a. Okay. If it were to be the root, it's going to be written at this place, be small, and be written at this place, in between this and this, for you to know whether it is a root or a coefficient. Look at this here now. Can you see where it is written? Okay, that is the fourth root. All right. So here now, what we'll do here is that, don't forget, this one does not have the power. We don't have any business with it. Okay, it does not have the power. Just like the other. Okay, I've erased it. Does not have any business. I have no business to do with this. So to apply that law here, 4, we have to separate 4 from it. Then this one that have the fractional roots, and if no number is written here, automatically square root. Okay, that's the standard square root automatically. So this one will become a to the power of m over 2. Because a has the power of m, numerator, the root will be the denominator. That will be the answer to this. Okay, this is not fourth root. Please don't make that mistake. So that's that about the laws of indices. Now I've talked about every basic thing you need to know about laws of indices and the mistake that we should avoid. Please let's try to watch this video repeatedly. Before your exam, try to watch it again so that we will not forget these rules. And before we go, please, we'll have some exercises for us to practice this law, few exercises. And don't forget to subscribe to my channel if you haven't. Please, as a way of supporting me, and so you can learn many mathematical insights like this. Hit that subscribe button.